Here is a solution to question number 3 from your test on create rational function for given conditions. Question 3 is, create a rational function with vertical asymptotes at x equals to 1 and range greater than 0. So this is a very interesting rational function, and the idea of having these 5 questions in one set is to expose you for variety in rational function. That is all I want you to know, right? So this question says that we have a vertical asymptote at x equals to 1. So let us say this is our vertical asymptote at x equals to 1, right? Create a rational function with vertical asymptote at x equals to 1 and range greater than 0. So range is greater than 0. That means, well, our rational function could be kind of like this. Is it okay? Could be kind of like this. So that is the rational function which we want, right? Whose equation we want. So this is your x and this is f of x. Now, can you tell me what that rational function could be? Okay, now think about it and then tell me the answer. Well, this is a way to look into it. Now, if you have a vertical asymptote here, that means you have a 0 of a quadratic function or something like, right? And we are doing reciprocal of that to get this. So you can think about a function like this. For example, let me say a function like this. Let me draw this function, right? And let us say equation of this function is, I'm trying to give you a hint so that you get your answer. So I'm saying this equation of this function is, let us say g of x is equals to, let's say this is 0 and this is 1, right? So we say x, we shift x into 1 unit whole square. So that is my function in red. So this is this function g of x, correct? Now if that is the function, then the reciprocal of this function, that means f of x, which is 1 of g of x, which you can say as equals to 1 over x minus 1 whole square, right? We'll have a sketch as shown in blue, right? Because it is always positive, therefore reciprocal will be always positive. And since it has one x-intercept at this point, we have a vertical asymptote, and that is along x equals to 1 as given in our condition, correct? So we'll get equation. So that leads us to the equation of a rational function 1 over x minus 1, which satisfies our condition. Do you appreciate it? So that is how we'll get. As the function approaches infinity, the reciprocal approaches 0, both sides. Positive infinity, so they are approaching from the positive side. And since we have a 0 at x equals to 1, we have a vertical asymptote for the reciprocal function 1 over x minus 1 whole square. Do you see that? That's how it is. And these are your invariant points where the two functions cross one another. If I put x equals to 0, I get gx equals to plus 1, right? So the invariant points are actually at y-intercept, right? At y equals to 1. So that is a perfect equation for the given situation. I hope you appreciate and understand how we got our equation, correct? Definitely, there could be more than one answer. In fact, you could write anything on the top in this case. I mean 1, 2, 3, 4, any number, right? And get similar kind of a function, correct? So that's how we are going to solve this. Okay, now let's look into the solution of the next question, which is also typical in itself. Thank you.